Good morning, good afternoon, and good evening. Welcome to the Crazy Hat Chemist. So here we go with another video here, and today we are going to discuss how to balance a chemical equation worksheet. Okay, here we go. Here are the rules for balancing chemical equations. Number one, after having the skeleton equation written, that is the correct formulas and the states of matter for both the reactants and the products, then balancing of the equation can occur. So actually, what you really need to do is you need to be watching this previous video that I just made, and it's how to write a chemical equation worksheet. So look this one up before you watch this video here. This is the necessary information. And then really what you need to do prior to all of this is you need to look at your ions and charges, your periodic trends, have those known, as well as look up ionic compounds, that entire unit of ionic compounds. So let's keep on going here. Number two, it is a relatively simple task to balance an equation. The same number of each atom must be on both sides of the reactant and the product side. But first, a few rules must be adhered to. A, the formulas of the reactants and products are not to be changed. This is assuming they were written correctly to begin with. B, only whole number coefficients can be written in front of the formulas. This does change when you go into higher levels of chemistry, but for right now, this is what most chemistry teachers follow. I, these are officially called stoichiometric coefficients, II. Coefficients are mathematically distributed into the entire formula in which they are assigned. III, fractional coefficients cannot be used. Number one, this rule will change as one moves further into chemistry, but for now, fractional coefficients are unacceptable. C, it is easiest to begin with the most complex and unusual formula. Whether it is on the reactant or product side does not matter. Let's scroll this on up just a little bit here. I, then pick an element and count the number of atoms. II. Then, using that same element, count the number of atoms on the other side of the equation. Number one, if the number of atoms differs, then place a whole number stoichiometric coefficient in front of the formula that needs more. III. Continue to another element and proceed to count the number of atoms on both sides of both the reactant and product sides. IV. It is best not to make a table. Just focus on one element at a time. This can be done in your head. I always see my chemistry students when they come into my chemistry class, whether it's here, honors chemistry, or advanced placement chemistry, and they have been taught in middle school to make these tables and to count the number of atoms on both sides. That is just tremendously tedious. Please do not do that. It just takes too darn long, and it doesn't really actually help you in the process. You should be able to keep these numbers in your head. Okay, number three. Example problem number one, to balance an unbalanced equation, we have chlorine gas plus lithium bromide aqueous produces bromine, that's a liquid, plus lithium chloride aqueous. Notice that both the chlorines and the bromines are not balanced. It does not matter which element one starts with. However, arbitrarily starting with chlorine will give the following intermediate step to balance the chlorines. Right? So there are two chlorines on the reactant side, one chlorine on the product side, for example. Okay, that's why there's a 2 coefficient. This is called a stoichiometric coefficient. I'll highlight that right there. This 2 distributes with the lithium and the chlorine. Letter C. Now notice that both the bromine and lithium atoms are unbalanced, as seen above, and both can be balanced simultaneously with the following. The balanced equation, there are 2 chlorines, 2 lithiums, 2 bromines, 2 bromines, 2 lithiums, 2 chlorines. The above equation is balanced correctly, and some key points to keep in mind. Number one, the formulas have not been changed. Number two, only whole number stoichiometric coefficients have been used to balance the equation. Number three, there is no other possible correct answer. Okay. All right, let's move on to another example problem. Here we go. Example problem number 2. Okay. Hey, by the way, this video is brought to you by None other than myself. That is the Crazy Hat Chemist. And please watch, like, subscribe, make comments, all that kind of good stuff. Number 4, example problem number 2 to balance an unbalanced equation. Aluminum oxide solid decomposes to aluminum and oxygen gas. B, notice that both the aluminum and oxygen atoms are unbalanced. It is common to balance the diatomic elements, last of which oxygen is an example of a diatomic. That is the diatomic right there. Therefore, starting with the aluminum atoms to yield the following. There's 2 aluminums here. I'm going to place a 2 right there. C. Now only the oxygen atoms are unbalanced. To balance these, use the greatest common factor between 3 and 2, the number of oxygen atoms on the reactant and product sides respectively. This yields the following. So for example, there are 3 oxygens on the reactant side. There are 2 oxygens on the product side. The greatest common factor between 3 and 2 is 6. So I'm going to put a 3 here. That's why that 3 is here. I'm going to put a 2 here. That's why that 2 is right there. Okay. D. Looking carefully at the above equation, one should notice that it is still not balanced. In fact, the aluminum atoms, which were balanced previously, are not unbalanced with the are unbalanced with the last step. Yes, are unbalanced with the last step. Therefore, rebalancing the aluminum atoms is the last step as shown below. So what we're going to do is we're going to change this 2 right here to a 4. A key point to keep in mind is that the very last step is to check if the equation is balanced. And how we do that is to do the following. 2 times 2, that's 4 aluminums. 2 times 3, that's 6 oxygens. 4 aluminums, the aluminums are balanced. 2 times 3, that's 6 oxygens. That's 3 times 2, that's 6 oxygens. Okay, we've got it. All right, let's flip this worksheet over and let's do a little bit more for some examples, and then we'll have some problems to solve out. All right, next one. Number 5, example number 3, example problem number 3 to balance an unbalanced equation, silver iodide solid, and this is a ferric carbonate solid, produces silver carbonate and iron 3 or ferric iodide. B, in the above unbalanced equation, there is no element of which is balanced. All elements are unbalanced. Typically, it is easiest to begin with the most complex and unusual formula for balancing. This would be the ferric carbonate. Balancing the iron atoms first to yield. So let's just check the iron. How many irons are on the product side? 1. How many irons are on the reactant side? 2. So therefore, this 2 stoichiometric coefficient is placed here. That will give us 2 irons on the product side and 2 irons on the reactant side. C. The next step is to continue with the balancing of atoms within the formula, ferric carbonate. The carbon atoms would be the next choice to yield. So how many carbon atoms are here? That's 3 times 1, that's 3. How many carbon atoms here? 1 times 1, that's 1. So there's 3 here, 1 here, and I need a 3. That's why this 3 coefficient is placed here. That will give us 3 times 1, 3 carbons, and 3 times 1, 3 carbons. D. The final step is to balance either the silver or the iodine atoms individually or simultaneously. Any choice will yield the same result. So how many silvers are here on the reactant side? 1. How many silvers are on the product side? 3 times 2, that's 6. How many iodines on the reactant side? 1. How many iodines on the product side? 2 times 3, that's 6. So there's 6 iodines and 6 silvers on the product side, and there's only 1 of each on the reactant side. So I want to place a 6 coefficient right there in the front. Again, check each element to verify the correct balancing of the equation. One that we did not check that we should check are the oxygens. So 3 times 3, that is 9 oxygens. 3 times 3, that is 9 oxygens. 6 silvers, 3 times 2, 6 silvers. 6 iodines, 2 times 3, 6 iodines. 2 irons, 2 irons. 3 carbons and 3 carbons. Yes, we have checked every element. It is balanced. We are good to go. So our stoichiometric coefficients at the end here of this one is a 6, a 1, a 3, and a 2. Those are our stoichiometric coefficients. This one is assumed. Let's scroll this on up just a little bit more and let's see what we can hammer out on this one. Example number 4. Number 6 says example problem number 4 to balance an unbalanced equation C3O8, so C3O8 gas plus O2 gas produces carbon dioxide gas and H2O, that's water liquid. B, this equation is a combustion reaction, and combustion reactions are always balanced in the following order. First carbon atoms, second hydrogen atoms, and finally oxygen atoms, a diatomic. This will give the following. So first is the carbons. How many carbons on the reactant side? 3. How many carbons on the product side? 1. So I'm going to place a 3 coefficient in front of the carbon dioxide. Then the hydrogen atoms. So how many hydrogen atoms? Oh, wait, we've got a problem on this one, so let's fix this one right here, right now. So let's see if we can make this correct. This should be an H. That's what that is. This should be an H. Now we can actually balance this. So let's make sure that we can actually do that. So how many hydrogens here? 8. How many hydrogens here? 2. So let's go back to this one. How many hydrogens? 8. How many hydrogens? 2. So I'm going to place a 4 right in front of that. That will give us a 4 right there. Perfect. Okay. And then D. And finally, the oxygen atoms must be counted on the product side. That's 3 times 2 equals 6. So right here, let's try this. 3 times 2, that's 6. Oxygens here, 4 times 1, that's 4. I'm going to add up that 6 and that 4 together. That's a total of 10. Okay. Oxygen atoms on the product side. The same number of oxygen atoms must be on the reactant side to give the final balanced equation. The final balanced equation is 5 right there. That will be 5 times 2. That's 10 oxygens. We already just checked our oxygens. So there are 3 carbons. 3. There are 8 hydrogens, that's 4 times 2, 8 hydrogens, and 5 times 2, that's 10 oxygens, that's 3 times 2, that's 6, plus 4, that's 10. All right, let's do some more example problems. We got 10 problems in which to balance here. So let's see if we can give this a try. All right. So let's see if we can get, let's just kind of zoom on in on this here so we can get this nice and large so that you can really get the full scope of everything. Okay. Remember, you are watching the Crazy Hat Chemist. All right, here we go. Balance the following chemical equations. NaOH plus H2SO4 produces Na2SO4 plus H2O. So I'm going to look for unusual elements first. That is a sulfur and a sulfur. There's 1 sulfur on the reactant side, 1 on the product side. But I do notice sodiums, 2 sodiums here on the product side. There's 1 on the reactant side. So I'm going to put a 2 coefficient in front of the sodium hydroxide. That will give us 2 sodiums, 2 oxygens, 2 hydrogens within this formula. Then the sulfurs are still balanced. The sodiums are now balanced. Now I need to balance either the hydrogens or the oxygens. So hydrogens on the reactant side is 2 times 1, that's 2. Plus 2, that's a total of 4 hydrogens. And over here, I have only 2. So I'm going to place a 2 in front of that water, and that will balance the hydrogens at 4. Now I'm going to check the oxygens. 2 times 1, that's 2 oxygens, plus 4, that's 6. 4 plus 2 times 1, that's 6. So that equation is balanced. Check. We're done with that one. Let's get the next one here. Chromic carbonate. Okay, there are 2 chromiums here on the reactant side, 2 chromiums on the product side. There are 3 carbons on this reactant side, and there's only 1 carbon. So I'm going to place a 3 in front of this carbon dioxide. That will give me 3 carbons on that product side. There are 9 oxygens. 3 times 2, that's 6. Plus 3, that's 9 oxygens. Check. That one is now balanced as well. Okay. All right. Perfect. Let's go for the next problem here. Number 3. We got magnesium plus ferric oxide produces iron and magnesium oxide. This appears to be the most complicated formula with the most numerous of elements here. I have 2 irons. I have 1. I'm going to place a 2 right in front here. I have 3 oxygens. I have 1. Place a 3 in front here. Notice that the magnesiums were balanced previously at 1 each, but now they're unbalanced. So 3 magnesiums on the product side. There's 1 here on the reactant side. I'm going to place a 3 on the product side. And now that is balanced. The next one is calcium hydroxide, and phosphoric acid produces water and calcium phosphate. This calcium phosphate right here on the product side is the most complicated formula with the most numerous of elements. That's where I'm going to start. I'm going to start with the most complicated thing. There are 3 calciums here on the product side. Now there are 3 on the reactant side. There are 2 phosphorus, not phosphates, but 2 phosphorus on the product side. And so that would be 2 on the reactant side now. Now I need to look at the number of hydrogens or oxygens. So you notice that this formula, calcium phosphate, has no hydrogens in it. So what we're going to do is we're going to balance the hydrogens and then check the oxygens, since this formula has both hydrogens and oxygens in it. So the number of hydrogens here with this 3 coefficient is 6. The number of hydrogens here is 6. So that's 6 plus 6, that's 12. I need 12 hydrogens here. That would give me a 6 here. 6 times 2, that's 12. I'm going to count the number of oxygens. That's 3 times 2, that's 6. 2 times 4, that's 8. So 6 and 8. And then over here I have 6 oxygens, and then 2 times 4, that's 8. So 6 and 8 again. So that's balanced. Perfect. I'm going to move this up here just slightly because we have some more reactions to do. All right. This next one here, number 5, I have magnesium plus nitrogen produces magnesium nitride. Okay, I have 2 nitrogens on this is the most complicated formula. This is where I'm going to start. I have 2 nitrogens and 2 nitrogens. The nitrogens are balanced, 3 magnesiums and 1. So I'm going to place a 3 right there like that. Done. All right, perfect. Keep on going. The next one here is potassium chlorate produces potassium chloride and oxygen. So the potassiums are balanced. The chlorines are balanced. The oxygens are not. This is 3 oxygens and 2 oxygens. We can use a fractional coefficient, which might be covered in another video. But other than that, we're going to use the greatest common factor, which is 3 and 2. That's a total of 6 oxygens on both sides. Now, the potassiums and chlorines, I have 1 on the product side and 2 on the reactant side. So I'm going to place a 2 right there like that. And now that will be balanced. Perfect. The next one is aluminum plus bromine produces aluminum bromide. The aluminums are balanced. The bromines, I have 3 on the product side, 2 on the reactant side. Again, the greatest common factor between 3 and 2 is 6. So I'm going to place a 2 right here and a 3 right here. That will give me 6 bromines on the reactant side and 6 bromines on the product side. The aluminums are now unbalanced, which they were before balanced. Now I'm going to have to place a 2 right there in front of that. All right, scaling this on up just a shad bit more. Oh, quick little station break. This video is produced, sponsored, and all that kind of good stuff by none other than myself, because I'm a one-man team here. I am the crazy hat chemist. So I hope you are having a fantastic day and learning a little bit of chemistry here on balancing equations. This next one here is aluminum hydroxide. Sulfuric acid produces aluminum sulfate and water. Okay, so on this problem here, we're going to start off with the most complicated formula, which is this aluminum sulfate. I have 2 aluminums, 1 aluminum. I'm going to place a 2 right here. I have 3 sulfurs, 1 sulfur. I'm going to place a 3 right there. This is very similar to problem number 4 that you can't see, but you can look at the previous problem number 4. Okay, I'm going to balance the waters. And how do I balance the waters? Just by balancing the hydrogens. How many hydrogens on the reactant side? 2 times 3, that's 6. 3 times 2, that's 6. That's a total of 12. I need 6 here, or a total of 12 here, which is 6 times 2. That's 12. The number of oxygens should be balanced. That's 3 times 4 oxygens. That's 12 plus the 6. 3 times 4, that's 12, plus the 2 times 3, that's 6 oxygens. So the number of oxygens are balanced as well. All right, second to last problem, I got chlorine gas reacts with potassium iodide to produce iodine and potassium chloride. So you can start wherever you want to here. There's 2 iodines here on the product side. There's 1 on the reactant side. I'm going to place a 2 right there. That gives me 2 potassiums on the reactant side, and I need 2 potassiums on the product side, and now that will also give me 2 chlorines on both reactant and product side. All right, we have one more problem to balance. Calcium hydroxide plus aluminum sulfate produces calcium sulfate and aluminum hydroxide. I'm going to start off with this most complex formula of aluminum sulfate. There are 2 aluminums here on the reactant side. I'm going to place a 2 in front of the aluminum hydroxide. There are 3 sulfurs on this reactant side. I'm going to place a 3 in front of the calcium sulfate. And then there are 3 calciums on this product side. I'm going to place a 3 in front of the calcium hydroxide. You should be able to check the number of oxygens and the number of hydrogens on both the reactant and product side. So 3 times 2 hydrogens, that's 6. 2 times 3 hydrogens, that's 6. Number of oxygens, 6 plus 12. Okay, number of oxygens, 12 plus 6. They're balanced as well. All right, fantastic. I hope you're having a great day and enjoy your day, and I hope you're learning some chemistry. I hope you have a fantastic afternoon, morning, evening, wherever you're at. And I love you, and I'll see you next time. Bye for now.